This is integrals with inverse trig functions. And basically what we're going to be doing is taking what our derivatives created from our inverse functions and using those as the starting point to reverse it back to its antiderivative. So if you look at this one, it's 1 over x square root of x squared plus 4x. You can see that that one is basically inverse secant. It's x square root of x squared minus 1. So that's the first place we're going to start and try to make this work. But if you notice, that's a 1 and that's a 4. So the little trick is to say that we use 4u squared instead of x squared. So what we're going to end up doing is putting a little 4 here so that we can factor it out. So whatever number we have here, you want to use that one here. And then we're going to change our x squared into a u squared. Now that's not what we're going to be using for the u substitution. We still want to square root both sides. So really it's 2u equals x. And you'll see why when we finish everything. So let's take our u substitution. This would be 2 du equals dx. And now let's substitute everything. So we get 1 over. And now our x here is 2u. Our x squared is 4u squared. See, they're all set up for us here. And then our du is 2 dx. So what I'm going to do is put the 2 here, du. So our dx is 2 du. And immediately cancel that 2 because we can. Okay, so the reason we put the 4 here, we want this to be 4u squared, is so we can factor out that 4, turning that 4 into a 1, and then we'll have our secant. Okay, so I'm going to move it over here. And so what we have is the integral of 1 over u square root. And then we put the 4 and we factor it out like that. And now I can basically take that square root of 4, which is 2, and turn it into this. Bring out the 2 all the way to the front. And there we have it. So now if I take out that half, because that's what that 2 on the denominator is, I end up with this. And so each of these up here, what we're really doing is if you just replace that with a u, right, it would turn it back into here. So the integral of this is going to give us inverse secant. The integral of this would be the inverse cotangent, and so on and so on. So you notice it's a u instead of an x, so that would just become a u. So this becomes 1/2 inverse secant of u instead, because again that's an x, we need a u. But we can't have u at the end, so we just go back and we substitute. So on this one, what I have to do is a little dividing. So if we solve for u, we end up with u equals x over 2. So again, all of our substitution is in that same location. It's right here. This is our sub area. And I just have to go back and grab it. So this becomes 1/2 inverse secant of x over 2. Oh, plus c, the one thing we always forget. And there you go. All right. If you look at the next one now, you'll notice there is no 1 plus x on the top. So the trick is to take that denominator and actually divide it into the 2. So if we take this, we can divide it, and we end up with 1 plus x. Oops, sorry, we're going to split it. 1 over 1 plus x squared dx plus the integral of x over like that. And now you can see that one is a dead match for the inverse tangent. So we can immediately just say, well, the integral of this has to be tangent x, because the derivative of inverse tangent x would be 1 over 1 plus x squared. So that matches. But there isn't one for this, and that's because this is just plain old u substitution. So if we go and say, well, u equals 1 plus x squared, and du equals 2x dx, you can see that that becomes the numerator. So what we're going to do is take and do this one off to the side over here with a little u substitution. So the x dx is sitting right here, so we're going to have an extra 2 that we need to move over. So let's rewrite it. Du over 2 equals x dx. Okay, and so now that is going to become du over 2. So we end up with 1/2 integral 1 du, and we know that the 1 plus x squared is u. And now we could just say that that's the natural log of u plus c. And u is equal to 1 plus x squared. So we end up with 1/2 natural log. And I'm getting rid of the absolute value because we have an x squared plus 1 that will always be positive and greater than 0. So plus 1/2 natural log 1 plus x squared dx. But basically it's always positive, so we can put that on there. And there we go. Oops. Let's move it over because, again, plus c. Slide this over a bit just so I can put plus c. And then we box it, and there we go. All right. The next trick is just plain old U-substitution. And if you look at it, you'd want to go, oh, well, 1 plus 2 cosine squared x. Well, if I do that, I'm going to bring down the 2. I'm going to get a cosine and a sine. It's not going to become the top. But if you go up here and you look and you go, wait, I can stop right there. I have a 1 over 1 plus x squared. Why don't I make cosine equal to u, and that'll turn into a 1 plus u squared. And then I can do my inverse tangent. Let's see if it works. So du equals negative sine x dx, and there's our sine. So I'm not going to even resubstitute. Let's just do it. Negative du equals sine x dx. It'd take me longer to talk about it than just to rewrite it. All right, so our sine x dx, so this right here is negative du. So we put a negative here, du. And then this becomes 1 plus u squared. So we have 1 over 1 plus u squared. Now we need to take our interval and redo it. So for x equals 0, we get u equals cosine of 0, which is 1. And for x equals pi over 2, we get u of cosine pi over 2, which is 0. So we're backwards. This is 1 to 0. But look, we got a negative sitting there. So 0 to 1, we can switch it and use that negative to do so. So we use that negative to switch them. All right, so 1 over 1 plus u squared. That is tangent u, inverse tangent u. Plus c. And then our u here is, oops, not plus c. This is an interval, 1 to 0. I was going to go back and just plug in the cosine, but we're not doing that here. This is a definite integral. So we plug in the 1. And if you remember, what we're doing here is working backwards. So if you think about our graph, this is just backwards. Or you can use the unit circle. But at pi over 4, we would get 1. At negative pi over 4, we would get negative 1. And it does that shape like this. So when does our tangent equal 1? It's at pi over 4. When does our tangent equal 0? It's at 0. And so that gives us pi over 4. And if you plug this in your calculator, this is a nice definite integral, so math 9 it, and it will come out to pi over 4. All right. Last one is just a plain U-substitution trick. So it's that same idea that we've been playing with here, that we need x squareds here. You can see them everywhere. So it doesn't matter if it's a minus or an x squared minus or a 1 minus x squared. It's always that needs to be x squared with a 1 down here. And so we use the trick of making it a 4u. Or we split it up so that we can get that 1 over 1 plus x squared. Or we use some u substitution here. So that's what we're using here. This needs to be a 1 plus x squared. So that we're dealing with these two here, most likely, right? So if that's a 1 plus x squared, then I need to make that into a u equals radical x. So that when I were to take and square it, I would get u squared equals x. So this will allow me to replace that x with a u squared. And so that's where I would start, my u equals rad x. And it's sitting right here, which also tells me that when I do this, I know I'm going to get 1 over 2 rad x dx when I take the integral. And so there is my radical x. So 2 du is equal to basically dx over rad x, and I can take that and substitute it. Okay. So now let's go back, and I know that my x here is equal to u squared. See, I like to write everything so it's a direct sub. So this would become 1, sorry, not 1, it would become 2 du. 2 du over 1 plus u squared. And you notice it's all u's now, right? So the dx over rad x is 2 du. the x is equal to u squared. And so again, where I'm getting it from is it's 1 plus x. So I'm thinking, oh, this could be 1 plus u squared. So if u squared is equal to x, then my u would equal radical x. Which works perfectly. Okay, so now I would get 2 integral 1 over 1 plus u squared du. We go back up. And that was our inverse tangent. So this becomes 2 inverse tangent of u plus c. And then we go back up and we say, well, u is rad x. I plug that in. So 2 inverse tangent of radical x plus c. All right. So it all has to do with these little tricks. These are ones you want to try first. So again, if you just see that it's an x squared minus 4, make a 4u squared equals x so that you'll be able to factor out that 4. If you see 2 on the top, try splitting it. If you see a cosine square with a 1, well, try setting u equal to cosine so that you can easily make that into a u squared. And if you see a 1 plus x, try making the x equal to u squared so that we would get 1 plus u squared, basically meaning you get u equals rad x. All right, little tricks. Thank you.